Let's try to prove statement by its contrapositive. So basically, what's contrapositive? In the previous video, we talked about proving by derivation. Here you can see it. Now we are gonna prove by contrapositive. So basically, contrapositive means, in simple words, if not A, then not B. For example, here you can see a question. Let x be an integer. If x in the power, if x squared is even, then x is even. Pause the video and try to think about that. So now let me explain what's going on here. That says, for example, even take real integer number. For example, 3 in the power of 2 is 9, right? 3 is not even number and 9 is non-even number. Or let's take 2. 2 is even and 2 in the power of 2 is also even number. Let's prove it by contrapositive. First, we are gonna say that if x is not even, then the product of x to x is not even too. Let me write that down in a formal way. Here you can see I try to prove it from my own words and in a more formal way. So basically I'm saying that, let's say here in the question there is said that x is even, right? If x squared is even, then x is even. Let's say, for example, x is not even, then x is not even, then x squared is odd, right? Assume x is not even, right? Since the product of two odd numbers results in an odd number, it follows that x squared equals x times x is odd. We have proved through contrapositive. Basically, how? If not A, then not B. And we proved that if x squared is odd, then x is odd. I hope you understand it. And let me give you another a bit more interesting and difficult example. Let's see another example for solving contrapositive problems. Here it says, let x be an element of integer numbers. If x squared minus 6x plus 5 is even, then x is odd. So what does this mean actually, and how can we solve it? Basically it says only if x squared minus 6x plus 5 is even, then x is odd, right? That means to solve it in contrapositive way, we have to make x even, and therefore show that if we make x even, then x squared minus 6x plus 5 will become odd, you know, contrapositive. This, we make this odd, we make this even, and show it. Let me write it in a written and formal way. Here I try to prove it in a full way. So basically what am I doing? As I said, we make x even, so that to show that when we make x even, then this expression becomes odd, okay, because we are proving it via contrapositive. And yeah, then since I have written since x is even, it can be written as 2k. Remember, if it's even, it can be written as 2k or 2a. If it is odd, then it's written 2k plus 1. Plus 1, if you see plus 1, that means it's an odd expression or an odd number, okay? Or 2k plus 1, that means it's an odd. If it's just 2k or 2a, that means it's an even, remember. Since x is even, it can be written as 2k. Okay, and then we substitute 2k for the expression for like x. Then you can see here we got this question. Then to show it that it's odd, basically, in the end you have to get plus 1. How? Basically, from solution. For example, it can be written as this, for example, 5 can be written 4 plus 1, right? And I've written it like this. Then I took 2, so basically I combined them and took 2 out of parentheses, and this is the expression I got. And plus 1, that means it's a not. Okay, if they weren't plus 1, it could mean that it's even number. Since it's here plus 1, this is an odd number. Yeah, I hope you understand it, guys. Thank you.